equations in physics, and they'll be represented in different ways, okay? And these stem from your other equations. In the past, I've showed you how they've been created, but I'm not going to do that this year. Partially because I think it's a bit beyond you and it confuses you. So I'm just going to give you the three big equations and explain what each of the variables mean. But before we do that, I'll actually give you the variables first. So we're going to use, and you're going to tell me what you think they mean. They're the five variables. What do we think VI stands for?
Velocity initial.
Yep, good. I'll put that in my pen. That's good. So I'm just going to write initial velocity. What's our standard unit for initial velocity?
Meters a second.
Phil? Yep. Final velocity. Unit? And when using these equations, it is very important that we use the right unit, as we saw yesterday. A. Acceleration. Alex?
Speed over time.
Oh, yeah, meters per second squared, thank you. Yep. Thank you. Unit? Good. And the final T? Time. Good. Now, I'm going to warn you, this will be presented in different ways. That's how I present it. Makes sense, correct? Oh, other way. Some people give them those symbols. U for initial velocity, V for final velocity, A for acceleration, this is the good one, S for displacement or distance, and T for time. And it's pretty cruel. Why is this one particularly cruel?
Because S is also used as speed.
We use S for speed. As much as I can possibly do it, I'm going to try and keep consistent with these variables. But be aware that you might come across these in your future studies. Yes, Alex?
If we're doing an exam and we have to write down these variables, does it matter which one we do?
Only if you're putting it into the equation, but no, it doesn't matter. No.
Will those other ones be on the interchange?
I will give you an equation sheet with these ones. So I'm going to try and be as consistent as possible, but if you're studying, for example, and you look up Khan Academy, they might have this representation. So I'm just getting you to write it down, so if you come across it and it's different, you know what that means. Happy with that? So here comes the three big equations. This is my favourite part of every year.
Fortunately, it's been struggle with this side all the time. Yeah, very much scary.
Number one, VF squared equals VI squared plus 2AS. Oh, there I go, 2AD.
So can we break that up just to break it up just to show
What do you mean break it up?
as in like VF times VF plus 2 times A.
If you want, but you'll probably want a square root. When you're rearranging, square rooting is probably what you'll be looking to do. So I would probably keep it in that form. Just because when you see VI times VI, you don't know to square root that. You're probably thinking I need to do something different. 2. I'll go probably the easiest one next.
How much space do we leave?
Just one line underneath is fine. V equals U plus. That's probably the kindest one, and that makes sense. Final velocity equals initial velocity plus acceleration times time. So if you're travelling at 2 meters per second and you accelerate at 1 meter per second for 5 seconds, your final velocity would be 2 plus 5, 7. Starting speed plus acceleration times time equals final speed. All right, probably the worst one. Displacement or distance equals initial speed times time plus half acceleration
Initial
times
velocity.
speed.
Is it initial velocity?
Yeah, initial velocity or speed is fine, yeah. That's a good point though, you can use either.
So long as we do velocity and displacement.
Yeah.